Hey guys, in this video we're going to be just doing a brief explanation over your assignment on DeltaMath on determining concavity. From the two videos on Edpuzzle, hopefully you were able to get a good understanding of what concavity is. Concavity is basically the shape of the graph. Think of it in that way. And the shape, so this is the shape of f of x. The shape is either sort of cupped up or cupped down. So concave up, sort of like cupped up, it's a cup. Concave down, I think I said in the video was, good way to describe it was a frown. Concave up is a cup, concave down is a frown. The way I think about it, just sort of, again, like if I had a cup of water, if it's concave down, it would sort of just run off of it. If it was concave up, it would hold the water in place. So what I'm going to do on this, first thing to notice, as I've always said when you're given a graph problem, is first of all, identify what the graph is of. The graph could be of the function, the graph could be of f prime, the graph could be of f double prime, which we will get to now. All right. So remember, all this information that you get from concavity, this is essentially f double prime of x. If you see a graph of f double prime of x, that's a graph of the concavity of the function. Okay. Now, how we can determine those, we're going to be using the derivative to do that. But in this particular video, we're going to be looking at the original function and the derivative. And then in the next video, we'll actually be finding the second derivative, setting that equal to 0 to find what we call the inflection points. Okay. Inflection points are where the graph changes from concave up to concave down. So these inflection points are where f double prime equals 0. And this is where graph changes from concave up to down or vice versa. So places where the concavity changes are called inflection points. So just like or places where a function changes from increasing to decreasing or goes from increasing to 0 to increasing, those were called critical points. Okay, critical points were zeros of the first derivative. Inflection points are zeros of the second derivative. So on this graph, let's see if we can identify these, and then we'll use the little tool that they have as well. So I'm just going to try to eyeball the inflection points, and then we'll actually find the exact value. Okay, so this function from here up to some point in the middle of here, this is concave up. It's like a cup, right? Water would sort of like stay in that cup. Then at some point in there, there is an inflection point, probably right around here, inflection point. And this graph switches to concave down. So it switches to concave down, 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 down. And then it's actually going to change again somewhere in here. There's another inflection point. And then it switches back to concave up. So you'll get better at identifying where exactly these occur. But you can start to just, again, identify the shape of this graph. Again, this is the graph of the function. The places where it changes from concave up to concave down, those are called inflection points. And we can be a little bit more precise. We're going to be using this derivative here, this little tool to find those. You could probably eyeball this and figure it out, but we're going to use this other little tool they give us. So essentially, you could probably say from like -9 to 0, probably it's concave up. From 0 to maybe 5 or so, it's concave down. And then it's concave up again from 5 to 10 is what I would say. Now this other tool that it gives us, what you do is you click on this yellow and you just sort of grab it. Maybe a little hard to see with all this other junk I got going on here. Let me go ahead and erase that so you can see it. Right. So we know there's two inflection points. So what happens when you grab this thing, just kind of move it slowly, and it's going to create, this is the graph of the first derivative. Okay. So first derivative graph, you'll kind of see what's happening here. All right. So this is going to tell us the exact points. And you kind of got to drive it slowly to get the whole graph, or else it just makes these points. All right, so these inflection points are places where the second derivative equals 0. Well, where does the second derivative equal 0? Another way of saying this is the mins and maxes of f prime of x. So if we're given the first derivative, which we have here, this orange one is the first derivative, f prime of x. If we're to find the mins and maxes of that, that actually tells us the inflection points, the places where it changes concavity. Just like if we were looking for sort of the mins and maxes of the first derivative, that tells us the critical points. If we're looking for the inflection points, places where it changes on concavity, we're sort of looking for the mins and maxes of the first derivative. I know it gets confusing when you mix up all of these derivatives and the original function, but basically we're looking for the maxes sort of where the slope of the tangent line is 0, right? Where f double prime of x equals 0, this would be a point where f double prime of x would equal 0, where the slope of the tangent line is 0. Okay, and another place where that would occur would be right here, because that's a minimum. So at this place, f double prime of x equals 0. So these are going to be our two inflection points, because they're the places where the first derivative has a min or a max. Okay, so we can probably go ahead and identify these now, just to kind of confirm what we were able to tell based on looking at the shape. So this is, it's concave up to start. We're asked to find where it's concave down. Okay, that's what we're asked to find. So it is concave up. You can see all the way through here, concave up, concave up, concave up, concave up. Now it does switch right here, because you can see there's a max there. It switches to concave down. This is all concave down, this section. So the section that we're looking for, the concave down section, is going to be from here up until, looks like actually about 4. So if we had guessed 5, it would have been off, because it is at 4. That's where the sort of the minimum occurs, right? At 5, it's actually increasing there. So that section is where it's concave down. All the rest is concave up. So we're just going to type in the interval 0 to 4. 0, 4. And again, there's no other mins or maxes on this first derivative, so there's no other places where it changes. All right. Let's go ahead and look at another one. If you need to rewind and like sort of pause that section where it, with all the table that I just wrote out, how we're going to identify these, you can do so. Again, I like to eyeball them first, and then we'll confirm it with the first derivative. All right, so it's definitely concave up from here, right? This is all concave up. It's going to switch at some point in this little area to concave down. So somewhere in here, it switches to concave down. And then it's going to, it's a little bit hard to tell here, but it looks to me like it briefly changes, we'll find out with the first derivative, to concave up here at some point. And then it actually switches back to concave down. There's some, because that's definitely down there. This is up, down. So we got an up interval, then it switches to a down, then it looks like it switches back to up briefly, and then back to down. So like I said, you'll get better at this the more that you practice it. Let's go ahead and use the first derivative to help us identify those. So we're going to be looking for the mins and maxes of the first derivative. They're going to tell us where the inflection points are. Just going to drag it back and forth here. All right. So if we go through and just circle the mins and maxes of that first derivative, that's going to tell us where the inflection points occur. It looks to me like, so based on what we did here, there should have been 3 inflection points. 1, 2, 3, right? 3 inflection points. So let's see if we can verify that. There definitely is a max up here. It looks like the max, a little hard to tell, but there's a max there, right? So there's going to be an inflection point. There's a min right here. And then there's a max here. So those are our 3 inflection points. All right, so it looks like these two we were pretty much dead on. And then this one looks like it needs to just be shifted a little bit more to up here. Okay, so let's go ahead and type in these intervals. We're supposed to find the places, which is actually inflection points. All right, so the 3 inflection points we found here, here, and here. And that one's going to be a little bit challenging. I think it's at -1, that first one. So right there about x equals -1. Then at x equals 4. And then a max there, x equals 7. So the inflection points, again, will occur at the extrema, you could say, the relative extrema, where the mins / maxes of f prime of x. So that's where they occur. Because those are places where the horizontal tangent line of the derivative would be 0. The derivative of the derivative. All right, so let's try those 3. Hopefully that first one's right. It is difficult to tell. We'll just give it a shot. All right, looks like we're good. Let's go ahead and try another one. Remember, there always is these help videos here. You can also watch or look at the examples. All right, this one, intervals concave down. I just like to approach them all the same way and then figure out what we're asking here. So it looks to me like this function is all concave down here. And then it's going to switch at some point, right? So this is all down, looks like to me. And then it switches to a concave up. So in here somewhere. And then it switches back to a down here. And then it's going to switch back to an up here. And then switches back to a down. All right, so let's see if we can figure these out. So it looks like there is, again, an inflection point around here, one around here, one around here, and one around here. So there would be, looks like 4 inflection points. Again, you'll get better and better at identifying the shapes as you go. Let's see if we can find the exact points by looking at the first derivative. We're going to be looking for the mins and the maxes of the first derivative. All right, so it's actually up there. It's the yellow thing, or orange thing, sorry. Remember, for it to be a min or a max, it has to change from increasing to decreasing or decreasing to increasing. All right. I think we're pretty much on for most of these. Yep. All right. Good. Okay, so it looks like we got a pretty good idea there. So our inflection points are going to occur with a different color. Here, there's a min, there's a max, there's another min, and then there's a max. So then we just need to identify the parts that it was concave down. So it's down from the -9 to the first inflection point, which is right here. It's down, right? So that's from -9 up to -3, it looks like. So let's go ahead and type that. It's down. Union. Okay, the next one, it's concave up for a little point, and then it goes back to down for that little stretch right here. So right there at the second inflection point, it switches back to concave down. So it'll stretch there from -1 to, looks like, +1, because that's where there's the next inflection point. So their intervals are always going to be from inflection point to inflection point. -1 to +1. And then it's back to concave up from this inflection point to the next inflection point here. Concave up, and then it switches back to concave down for that last little stretch there. Last little stretch is concave down. So that would be from, it looks like 5, right? 5 is where that max is, to +9. So hopefully you're starting to get the hang of this. Again, I like to identify them on the original graph of the function first, and then just kind of confirm them with dragging this thing and looking at the derivative. If you are struggling with this, then please feel free to reach out to me.